Before we begin, let's say hi to both Jenna and Jason. Hi, Jenna.
Hello, Jenna and Jason.
Sorry you're not here to hear this incredibly exciting math lesson.
Sorry.
No, you don't. That's not a
Whatever he
repeat.
says.
That's not a repeat after me song.
Okay, here we go. Solving systems of equations by elimination. Did I give everybody, this is your notes, by the way. Did I give everybody a piece? And it is just like it says, you are solving these things by getting rid of a letter. That's why it's eliminating. You are getting rid of one entire letter there. Now it's based on this thought. Give me an addition problem, Jaden. Any addition problem. Make it easy because I don't want to go real hard here. 2 plus 2 equals 4. Give me one that, sure, I'll say 2 plus 2 equals 4. And Brianna, give me another addition problem. Actually, it could be subtraction. Doesn't matter. Give me addition problem.
4
Is what? 4 plus 3 is?
7.
7. There's a little thing here in math that says as long as you got 2 equations, you can add them together and you'll still get a true equation. In other words, 4 plus 2 is 6, 3 plus 2 is 5, and 4 plus 7 is 11. Does not 6 plus 5 equal 11? It's amazing. Well, take a look and see what happens here. If I have these two equations, negative 3x plus y equals negative 12, and I have negative 2x, same equation, I have changed it, right? Minus y equals negative 3, and I add them together, what is negative 3x minus 2x? Don't say 1x, please. Negative 3 and negative 2, Elijah, you're my go-to guy here. Negative 5x's. Here's where your gasp of relief and excitement comes. What is y minus y? Keith? Nothing. It's gone away. It has been eliminated. Poof. And what is negative 12 minus 3? Negative 15. So now you've gotten rid of a letter. You can just solve that for x by doing what, Brooklyn? Here's where you come in. You're not still thinking about that comment you were going to make that you decided not to make, did you?
No,
It's gone,
I
isn't
was
it?
writing things down, so.
Yeah, but it's still equation. People, everything's equation. They don't change. What is negative 5x equals negative 15? I solve it by?
Divide.
By? What's next to the x?
By.
Thank you, Grace. Yeah, divide by negative 5, divide by negative 5. X equals 3, boys and girls. No substitution, no blah, 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 no graphing, no nothing. X is 3. And then once you find out what x is 3, here's where it gets a little more tough because these are harder to solve when you put this number in. You put 3 in for x in either one of these, and you have to find out what y is. It doesn't matter which one. You can pick whichever one you think is easier. I don't know. I'll pick this one just because. Negative 2 times x, which was 3, minus y equals negative 3. Negative 6 minus y is negative 3. Add 6. Add 6. I get negative y equals positive 3. So y equals, ladies and gentlemen, negative 3. You just take your answer, put it back into one of those equations. But it is so much simpler. So much simpler. Uh-oh. Is that a question or you just? No. So much simpler than substitution or graphing. Guaranteed if you graph them, they would cross at those points. Guaranteed if you solve this for y and substitute it in, you'd still get that same answer. Now let's look at number 2. Same exact thing, right? What happens when I add them together? What is negative x plus x? Right. Nothing. 6y plus y is 7y. Negative 5 plus 5, 0. So guess what y equals? Remember, you are allowed to have a 7 on the bottom. You can't have the 0 on the bottom. If you get a 0 on the bottom anytime, then you have to say that this is no solution. So y equals 0. If I put 0 in for y, what number plus 0 is 5? X would have to be 5. Now, you are saying, now let me look at the next slide. Let's see what the next thing says here. I can't. Where am I even at?
Did I do that one? Did I do that one? Did I do this one? That has nothing on it. Oh, yes. Here is, listen. Somebody's going to say, surely it can't be that easy always. Surely it can't be that easy always. You can call me Shirley, and it's not that easy always. Look at this one. If you add these together, you add this together, you get negative 15. You add that together, you get negative 14. You add that, you get 8. Nothing is eliminated, right? Which is where you boo, because then it's not going to work. It's not eliminated. Boo! But, ladies and gentlemen, if this happens, you have to manipulate one of the equations, or maybe both of them, so that it does cross off. In other words, this. This looks promising because they're both 7s, but the problem is, when I add them together, they're not opposites or cross off. Well, what would this bottom one have to be in order for it to cross off? Thanks, Kate says a positive 7. Kate, what would I do to it to make it a positive 7?
Add a line.
Yes, but that doesn't, math, you just can't add lines. We have to talk mathematical operations here. Here's the deal with this. Sometimes you are going to have to do some stuff here to make these opposites. If this was a positive 7, everything would be good. Well, how do I make it a positive 7? I would multiply it by a negative 1. Because a negative 1 times that gives me positive 7y. The problem with that is you can't just be selective and pull one term of a whole equation out and do that. You need to multiply everything in that equation by a negative 1. Which means this also changes to a positive 7x, and this would stay 0 because 0 is neither positive or negative, it doesn't change signs. You got that? If you have to, you are going to have to multiply every term by the same thing to get them to be opposites. You need to make one of the terms opposite. And you could multiply, you might have had to multiply this by a 2, maybe by a 4, but everything would have to be multiplied by that. And then here comes our elimination. Negative 8x plus 7x is a negative x. The 7's go away because they're the opposites. Negative 8 and 0 is a negative 8. So what is x? X is in fact a positive 8. What is my y going to be? Again, this is probably the hardest part about this. You can pick either one you want to do. Let's pick this one and do. If I put 8 in for x, 7 times 8 is 56. I subtract that over here. It becomes a minus 56. Divided by a positive 7. Y looks like to me it's negative 8. I can only hope I was right on that. Does that sound doable for most of you? Yes. I love participation. You guys are just right in the ballpark. Don't worry. I get paid whether you learn anything or not, just so you know. I get paid not a lot whether you learn anything or not. Okay, here's one. Take a look at this one. Here's the multi-million-dollar question. This is actually your homework tomorrow, so for tomorrow, so it would pay for you. It would pay for you to pay a small little attention here. Somebody, tell me, if I add them together, they are not opposites. They won't cross off. What do I need to do? And there's, by the way, lots of different answers. Oh, wait. I don't think I want this one. Can I change that? I don't want this one just yet. I want this one maybe. Yes. This one. Oh, I don't know if this one's. Wait, was this on?
Yeah, that's all.
I don't want that one because I think that one's too easy. How about this one? This one I just did?
Yeah.
Yes. Oh no, I do want this one. Sorry, my bad. My bad. Somebody who has not answered. Luke Franklin. How am I going to get some terms to be eliminated there? Because if I add them together now, nothing happens to my benefit. What would you do? How could you change what in order to get something to be opposite so that when you add them together, they go away? Suggestions?
Multiply by negative 2.
Anybody think that that's a great idea? I agree, Luke. Everybody else in here disagrees, but I'm going to tell you yes. Why negative 2, Luke?
Because it changes the
Yeah, this is the easiest one because 7 and 14 are like multiples. 14 is a multiple of 7. Okay? You could look at these, but what can you multiply 2 by to get to 7? Yeah. What do you multiply 7 by to get 2? Yeah. You can take 2 times 7, and it needs to be opposite. So Luke said, let's multiply everything by -2. Well, let's do that. That was exactly what I wanted to happen at this point. Sorry, Jenna. Sorry, Jason. Hope you're feeling better. Where were we at? -2. So here's the deal. -2, -2, -2. I, by the way, am going to multiply and rewrite them down here, so how's that? What is -2 times 7x? -14x. What is -2 times a -7y? Positive 14y. And what is -2 times 28? -56. Stop me there if that didn't make any sense. It's multiplication. You should be able to figure that out. What happens when I add them all together or combine them? X's go away because they are opposite. 14 and 2 is 16y. And -24 or -56 and 24 is what? 32? Negative? Does it work out? Absolutely. Divide by 16. Divide by 16. Y is -2. What will x be? I don't know. Where do you put it back in? I'll put it back in right here. If y is -2, 2 times -2 is -4. Add 4 to 24 to get it over there. It's 28. 14 goes into 28 twice. Granted, I did that really fast, but we still happy? Nobody's falling asleep yet, so I must be on my A game today. All right. Somebody say, does it get any harder?
Yeah.
Harder. That's where this one, here you go. This will be the hardest possible problem you will face today, probably. Look at all of those numbers and letters. None of them seem to match up. Oh no, what can I do? I do have a small problem there. I wonder if this is going to work out. I see both of those equations are different, and yet they both equal 20. Interesting. Elijah, walk me through this. What do you think?
We can multiply them all by a fraction.
All right, that's going to be a little more work than I think we want to do. First of all, I avoid fractions like the plague. I also avoid cliches like the plague. Thanks, Grace. Did you even get that?
Yeah.
Here's the deal, Carol Winkleman. If you look at it, none of these are multiples of the other one. I mean, I can't multiply 2 by anything to get 5. I can't multiply 8 by anything to get 5. I can't multiply 5 by anything to get that, or 5 by that. Occasionally, ladies and gentlemen, you're going to have to actually multiply both equations by numbers. And this would be one of those cases. And let me give you a little clue. You do this all the time when you find common denominators of fractions. Okay? In other words, if I had 8 and 5, if I had 1/8 and 1/5 as fractions, what would my bottom number be if I were adding them together? 40, which would mean that's the lowest thing that I would try to switch both of these to, which means I would have to multiply the bottom ones by 8, because that would give me my 40 there, and the top ones by 5, because that would give me 40 on the top. The only problem with that is that still isn't quite right because of what? I do get 40s there, but Keith,
They're both negative.
yeah, they would both be negatives. When I add them, I would just get like -80. So I have to think in advance here. One of them I need to multiply by a negative. And it doesn't matter, it's your call. Delaney, which one? Pick one. You want to multiply by -5 on the top or -8 on the bottom? Alright, so I'm going to change all these. So that gives me a positive 40 on top. You got that? This is worst case scenario, the most work you're going to have to do with elimination. But could you imagine trying to do substitution with it? Ain't going to work. Graphing them doesn't seem very easy. So I will rewrite both of these equations here. Let's do the top one first. What do I get? Negative 8 times negative 5 is a positive 40x. Negative 5 times positive 2 is a negative 10y. Negative 5 times 20 is a negative 100. Got it? Multiplying the second one by that wonderful 8 that we figured there. Negative 5 times 8 is a negative 40, which is what we want because look at the opposite. Positive 5 times 8 is a positive 40y. And 8 times 20 is 160. Doesn't that look better, kids? Aren't you glad you came to school today despite your excessive fever and so forth? 40 minus 40 is nothing. Negative 10 plus 40, you get 30y. 160 minus 100 is 60. So y equals 2. And then you can take your 2 and put it in any equation you feel like. You've got 4 to choose from. I don't know. Who's got a suggestion? Manny, Marco, which one shall we do just for fun? Pick one. It doesn't matter.
Negative 5x.
Alright, I'm gonna write it over here just so people don't get so confused like the last time I did this. Here's my starting equation. I know y is 2, so I put 2 in for y right here. Negative 5x plus 10 equals 20. Subtract 10 to solve the equation. Subtract 10, I get 10. Negative 5x equals 10 divided by negative 5 divided by negative 5. X is a negative 2. Thank you for stopping by math class today. Who feels that you're just better people all around because of this math lesson? Sometimes your lack of enthusiasm hurts me sometimes. Not today, but okay. Do you feel you're ready to jump on board the solving systems of equations by elimination bandwagon?
No, not really, but let's do
Yes.
it anyway.